Welcome to Math with Mrs. Cox. We are on Chapter 6, Lesson 8, page 423. We are talking about multiplication properties. These are similar to the addition properties we talked about a few weeks ago, except there is a few slight differences that we'll go over shortly. Let's begin. A coach had 16 players in each of two groups. Each player scored 5 goals. Find the total number of goals scored. And here's how they put it together. 16 players, 2 groups, 5 goals. You can easily multiply 2 and 5 and change the way the numbers are grouped. This is called the associative property. All right, 2 times 5 is 10. And then we can mentally multiply 16 times 10 for 160. And because of the associative property, we were able to do this problem in our head. So the total number of goals that is scored is 160. Example 2, the commutative property. Remember, in addition, the example of the commutative property was, think of your parents driving to work. They're commuting to work, and they turn around and commute from work back home. And so the only thing that changes is the order. And so that's a similar thing with a commutative property. Looking over here, we can see there's a 35.5 and a 35.5. Here's the equal sign. To make it even on both sides, or the same trip both ways, we need to add a 17 right there. So the unknown number is 17. That gives us the answer using the commutative property. Okay, the only difference now is the identity property. With multiplication, the identity property, we use the number 1. In addition, we added a 0, and it would still keep its identity. But in multiplication, if we multiply anything by 1, it still keeps its identity. So that is the identity property. Hey, looking at these problems, let's see if we can figure out which problem belongs to which property. Right here we have the equal sign, and both sides have 100 and both sides have a 6.2. So we've just changed the order and it still equals the same. So that would be the commutative. Right here we associate different numbers together, but it doesn't change the end product. So that would be our associative property. And right here we have times 1. That's kind of a dead giveaway for the identity property. So the number does not lose its identity. Number 4, use the properties multiplication to find each product mentally. Show your steps and identify the properties that you used. Okay, I'm looking at number 4, and in my head, it's a lot easier for me to multiply 2 times 50, because I know 2 times 50 is going to be 100. Then I'll bring down what's left over, and I have 1.5 times 100. And I know with our last chapter that we just did, I have 2 zeros here, so then I have my answer, and I move it over 2 spots. So my answer is going to be 510. And the property that I used on that is going to be associative. Number 5, I'm going to look at this problem, and the easiest way for me to do this mentally, I think, would be to associate 4 times 2.5. Now, if I do 2.5, it's really close to 25. And I know 25 times 4 is 100. And now I'm going to pay attention to the 0, and I know that the 0 is going to come over that way. So now I have a number that's 10 times 6. And in my head, I know that is 60. So I'm going to put an A right here, saying that I use the associative property. Number 9. Looking at this one, there isn't a 1, so I can't use identity property. I'm probably going to use the associative property. I don't know, it's just a little bit easier. That's kind of like my favorite. I'm going to times these two together because I know that would equal 1,000. And then using 9.8 times 1,000, it's going to go over 1, 2, 3 numbers. So I'm going to have 9, 8 with 2 zeros behind it is going to be my answer. And that's where I also use the associative property. What can I say? It's my favorite because I'm going to use it right here too. 50 times 20, I know that 5 times 2 is 10, plus 2 more zeros is 1,000. Then I have 1.4. So if I have 1.4 and I move it over 1, 2, 3, because I have 1, 2, 3 zeros, my answer is going to be 1,400. That's my total answer. And again, I use the associative property on that one. That's how I'm going to label that one. All right, right here, we're finally going to get to use some of the other properties. Circle which property is used. 19.5 times something equals 19.5. I'd have to say a beautiful 1, and that's going to be its identity, because it's not going to lose its identity. And on this one, they have an equal sign, which tells us they are going to probably be a commutative property. I have a 65 here, 65 here, 34 here. I imagine a 34 is what we're going to need. So then we have our commutative property. And number 10. We have, looks like the commutative one again, because we have a 2.1 and a 2.1. All we're missing is the 4.3. And then this one right here, look at this one. They're associating these numbers together. Over here, they're associating these numbers together, but they're still all the same numbers. So it's not commutative, even though they're the same numbers, because they're associating numbers. So I'm going to say the only number I don't see on this other side is a 2, and it's going to be the associative property, because they are grouping specific groups of numbers together. All right, that's what our page is going to look like. Join me on the next page. Elijah and 2 of his friends, so how many bodies are there? That's right, there's 3 bodies, are each paid $20 per an afternoon for stuffing envelopes. If they work 5 afternoons, what is the total amount of their earnings? Okay, so we have 3 people that are paid $20. And we're going to times that by 5. So what's the total amount that they're paid? Well, 3 times 20 is 60, so we have $60 times 5. So they're paid $300. Number 13, replace the gray square in 8.7 times blank times 5 with a number greater than 10, so the product is easy to find mentally. Oh, okay. Well, let me think. I would probably choose maybe 20, because what I can do there, I'm going to put it right here, 20, semicolon. All right, take 2. If 20 is a factor, then you could use the associative property to write the original equation right here as this equation that's a lot easier to figure out mentally. Since 20 times 5 is easier to figure out as 100, then we can just move the decimal point over 2 spots and get 870. Brain builders. I kind of feel that last one should have belonged in the brain builder. Okay, number 14. Each juice box contains 6.4 ounces. Each value pack of juice holds 10 juice boxes. If you have 50, remember 50 looks like this, 50 value packs, do you have 4,000 ounces of juice? Explain. Okay, we can figure this out. So we're going to do 6.4 times 10, because that's our first 2 numbers, right? And then we're going to say, put that in a little parentheses because we're associating those together. Then we're going to times it by 50 packs. Okay? So let's look at that. 6 times 4 is going to be 64. Then we're going to times it by 50. 5 times 4 is 20. 5 times 6 is 30. Plus 2 is 3,200. So 3,200, they want us to have 4,000. No, we're only going to have 3,200 ounces. So we're going to put a little less than sign. The 4, let me move my square, 4,000, which is what they were requiring. So no, we will not have enough juice. Or we will not have enough, the 4,000 ounces of juice. All right, number 15, write a problem you could solve mentally using 2 multiplication properties. Explain how the properties can help you solve the problem. Okay, so when you have a problem like this, it's really easy to just go ahead and grab one from the previous page. So you can let's grab number 1, shall we? So let's grab that we could use 3 times 20 times 5 would equal the same as if we did 5 times 20 times 3. And that would be our commutative property. Or we could also write it like this, 3 times 20 associated that times 5 is going to equal the same as if we do 3 times 20 times 5. They're both going to make the same answer, and we're going to use the associative property there. So we showed an example of having to use the commutative property and how to use the associative property. Number 16, how do multiplication properties help me find products mentally? Provide an example to illustrate your explanation. Well, let's just use the previous example we used on 15. Let's not make it any harder on ourselves. I'm going to say that I'm going to use 3 times 20, put it in a parentheses for association, times 5. Okay, and there you go.